For today's video, we're talking about solving two-step equations. So your learning target is I can solve equations by undoing. Please write down the date that you're watching this. Write down your I know. You may not know much about solving, but you know what an equation is, so you can definitely write about that. And then there is no vocabulary today. So make sure you have all this written down, pausing the video now, and restart when you're ready. So talking about solving equations by undoing. When we do this, we are going to be using what's called inverse operations. Inverse operations basically are the opposite. So when we are undoing, we are going to be doing the opposite of an operation. So for example, let's say I had x minus 5 equals 3. Now, you may be able to really quickly and easily do this in your head. All I'm asking is for what minus 5 would equal 3. But if I wanted to solve this by undoing with inverse or opposite operations, I would think about what is the opposite of subtract? The opposite of subtract is addition. So here I have minus 5. I want to undo minus 5 by adding 5. Now, with the equal sign here, the equal sign is my great balancer. Anything I do on one side of the equal sign, I have to also do to the other side of the equal sign. So a lot of times I like to draw a line through the equal sign like this, because that's going to remind us to keep everything balanced. Anything I change on the left side, I have to also change on the right. It all has to stay balanced. So if I'm going to undo subtract 5 by adding 5 on the left, I have to also add 5 on the right. Now, because subtract 5 and add 5 are opposites, these two things cancel each other out. And I'm left with just an x, and then equals 8. Now I can go back and check this. I want to know, does 8 plus 5, does that equal 3? And the answer is yes. So when we're solving by undoing, we're just using the opposite operation. We're getting rid of everything that is on the same side as the x. Our goal is to get this x by itself so we know what value makes this equation true. What value of x makes this true? And we can do this for any operation. If we had m plus 4 equals 10. Well, in this case, if I put my line to the equal sign, the opposite of addition is subtract. So instead of adding 4 here, to get rid of adding 4, I would subtract 4, which means I will subtract 4 over here as well. Adding and subtracting cancel out, and I'm left with m equals 10 minus 4 is 6, and I can check this. If I put 6 where the m was, I want to know, does 6 plus 4, does that equal 10? Well, yes, it does. So the solution works. I can do the same thing with multiplication and division. So if I have 5 times y equals 30, well, to undo multiplication, the opposite of multiplication is division. So instead of times 5, I'm going to divide by 5. That cancels out, and I'm left with y equals 30 divided by 5 is 6. Checking again. If I put 6 where the y is, I would have 5 times 6. 5 times 6, does that equal 30? Yes. So this works. I could do the same if there was a division. If there was a division in my original problem, I would undo it by adding. So with these, it's fairly easy. You could probably do most of these in your head. But this method is going to help us solve harder problems. And the first type of harder problem is a two-step equation. So a two-step equation looks like this. It's going to be something like 2x plus 3 equals 11. This is called a two-step equation because I have two operations. I have the times and I have a plus. So the rule here that we're going to want to follow is that first we're going to undo our addition and subtraction. Then we can undo our multiplication and division. So, for example, with this problem, always the first thing I like to do is draw my line through my equal sign. Again, the purpose of this is to remember that whatever I do on one side of the equal sign, I have to also do on the other side of the equal sign. So, remembering that there's two operations I have to do here. I have to undo multiplication and I have to undo addition. Well, my rule says first I have to undo addition and subtraction. So in this case, the first thing I want to undo is that addition. Well, the opposite of adding 3 is subtracting 3. So I'll write subtract 3 here, and that will cancel that. To stay balanced, that means I have to also subtract 3 on that side. On the left side now, I'm just left with 2 times x. And on the other side, when I do 11 minus 3, I get 8. We're not done. The next thing we need to do is say, okay, now I know that 2 times something equals 8. Remember, this is multiplication, invisible between the 2 and the x. To undo multiplication, I need to do the opposite, which is division. So I'm going to divide by 2 and divide by 2 on the other side as well to keep things balanced. Now the times 2 and divide by 2 cancel out because they're opposites. All I'm left with on the left is x, which was my goal. I was trying to get x by itself the whole time. And on the other side, I have 8 divided by 2, which is 4. As before, I can check my answer. I'm just going to take this 4 and I'm going to put it where the x is over there. So I'll do 2 times 4 plus 3. And I want to know if that equals 11. Well, 2 times 4 is 8, and 8 plus 3 does in fact equal 11. So my answer worked. So I'm going to do one more example for you here so you can see how this works. This case, we're going to do y divided by 3 sorry, not 3, 7. I looked at the wrong problem. Y divided by 7 minus 4 equals 3. Y divided by 7 minus 4 equals 3. Again, following our rule, we want to first undo addition and subtraction, then undo multiplication, division. So the equal sign. And the first thing I need to undo is the minus 4. As always, my goal is to get y, my variable, by itself, so I know what value this is. So subtract 4, the opposite is add 4, so I will add 4 to both sides. That cancels out. On this side, I'm left with y divided by 7, and on the other side, I have 7. Now I have y divided by 7. The opposite of divide by 7 is multiply by 7. So I need to multiply by 7 on each side. That cancels out. Divide by 7 and multiply by 7. I'm left with y equals 7 times 7, which is 49. As always, going back to check my work, putting 49 in for my y here, I would have 49 divided by 7 minus 4, and I want to know if that equals 3. 49 divided by 7 is 7, and 7 minus 4 does equal 3, so yes. this checks out. Really, really important thing when you're solving all of these is that you follow the rule. First, undoing addition and subtraction, then undoing multiplication and division. As always, please let me know if you have any questions, and have a great day.